So in the first question, you're asked to plot the given point in a rectangular coordinate system. So this is pretty straightforward. So this is your rectangular coordinate system. On this horizontal axis, we will call the independent variable the x-axis, and this is the y-axis, which is any dependent variable. So this ordered pair 0, -3 means that 0 units on the x-axis and -3 on the y. So this point in here is 0, -3. So whenever you plot a point, you have to label it right next to it. So the second point given to you is -5 halves, 3 halves. So what is -5 halves? It's nothing but -2.5, right? 3 halves is 1.5. So if you think about it like that, the first x coordinate is between -2 and -3. So that's somewhere here, right? And then 1.5 is between 1 and 2 on the positive y. So somewhere here. So this point that you are looking for is where these two meet, and this is -5 halves, 3 halves. Okay. In the next question, you're asked to graph these two equations, and they have given you a set of x values to use. So what I'm going to do is I'm going to create a small table here, and in this table, I'm going to put all the x values. So -3, -2, -1, 0, 1, 2, 3. So these are the x values that you want, okay? So I'm going to just, okay. So the equation that I want to graph first is absolute value of x minus 1. So suppose if you put this equation in and you plug in, your y value will become absolute value of -3 minus 1. The absolute value is going to take any number, negative or positive, and convert it into the positive equivalent. So -3 is going to become 3, and 3 minus 1 is 2. So this is what goes here, right? And likewise, you're going to continue filling it up, and you're going to end up with -2, absolute value is 2, 2 minus 1 is 1. -1, absolute value is 1, 1 minus 1 is 0. Absolute value of 0 is 0, 0 minus 1 is -1, 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2. And so if you plot these points, what do you have? -3, comma 2 is your first point. -2, 1 is your next point. -1, 0 is here. 0, -1 is here. 1, 0 is here. 2, 1 is here. And 3, 2 is here. And when you connect it all, you're going to have something like this. And you extend it on both sides. And that's your graph. Okay. And a very good graph should have all your points labeled. So the good thing to do would be to label this as 0, -1. I would say at least please label 3 points at least on the graph, like so. Okay. Now let's do the next one here. -x² is the next equation. So plug in. First, use your order of operations. The negative is outside, and this is what you have. And -3 squared, any number when squared becomes positive. So this becomes -9, right? Because the negative is outside. So this becomes 9, and negative of 9 is -9. Okay, so now that you have that, let's fill everything up. So this is going to be -9, -4, -1, 0, -1, -4, -9. So when you plot this, -3, -9 is here. -2, -4 is here. negative 1 is here. I'm sorry, here. Then 0, 0 is here. 1, negative 1 is here. 2, negative 4 is here. And then 3, negative 9 is here. So your graph is going to be a U-shaped graph facing downwards. Okay. And this is the graph of y equals negative x squared. Here, the question is asking you to look at the graph and then determine or whatever is asked of you. The first question is asking you for the x-intercepts. So what are the x-intercepts wherever your graph touches the x-axis or your x-intercepts? So here it looks like the x-intercepts are 1, comma 0 and negative 2, comma 0. So that's where your graph touches the x-axis. Where does your graph touch the y-axis? It touches here, which is 0, comma 2. So all x-intercepts will have 0 for y and all y-intercepts will have 0 for x. Okay. In the next question, it's asking you to check whether solve and check. Okay. So let's do this. So I'm going to do the first one here. 3 times x minus 2 plus 7 is 2 times x plus 5. The first thing you will do is distribute, okay, and both sides. So you have 3x minus 6 plus 7 is 2x plus 10. And combine the like terms on each side first, which means negative 6 plus 7 is positive 1, right? So this becomes 3x plus 1 is 2x plus 10. I'm going to take it here and continue. So I have 3x plus 1 is 2x plus 10. So if you're used to subtracting, so my goal is to get this over here and get this over here. So I want to collect all the variables to the left side, right? So which means I will subtract 2x from both sides and I will subtract 1 from both sides. And that gives me x equals 9 as my answer. So I check. How do I check? I plug it back in and check if my answer is correct. So I have 3 times 9 minus 2 plus 7. Is it equal to 2 times 9 plus 5? Let's check. 9 minus 2 is 7. 3 times 7 is 21. And then this one will be 2 times 14 is 28. 28 is equal to 28. So our answer is correct. So next one is this one. So I'm going to distribute. So I have 2x minus 2 plus 3 is x minus 3x minus 3. So here you're distributing the negative 3 to both terms, right? So you have to be careful. Now combine these two like terms and combine these two like terms. So you have 2x plus 1 is negative 2x minus 3. So when this negative 2x goes to the left, it becomes positive 2x. When this one goes to the right, it becomes negative 1. So I have 4x equals negative 4, which means x equals negative 1. Then I perform a check. So I have 2 times negative 1 minus 1 plus 3 is negative 1 minus 3 times negative 1 plus 1. Okay. Negative 1 minus 1 is negative 2. 2 times negative 2 is negative 4 plus 3 is equal to, this is 0. 0 multiplied with anything is 0. Negative 1 is negative 1. So it's correct. Okay. So now what you have is rational equations. So you have a fraction involved, all right? So let's do the first one. In the first one, you see how this x doesn't have a fraction. So if you want, if it helps you, you can think of 1 as the denominator, if it helps you, okay? So then look at all your denominators. You have 5, 10, and 2. So the LCD of 5, 10, and 2 is 10. So I'm going to multiply each term with 10. As long as you multiply with the same number, you are not changing the value of your equation, right? So everything remains the same. So now this 10 goes into 5 2 times, 10 goes into 1 10 times, 10 goes into 10 1 time, 10 goes into 2 5 times. Then you distribute. 2 times 3x is 6x minus 10x equals x minus 25. So then I move the x over to the left. I'm sorry. Let's combine the like terms here, right? Okay, sorry. Let's do that first. So combine the like terms on the left-hand side. So I have negative 4x equals x minus 25. Now I move the x to the left and then I divide by negative 5. X equals 5 is my answer. Okay, makes sense? So once you multiply by the least common denominator, your fractions, your denominator will go away and you will end up with a simple linear equation. So now let's do the second one. In the second one, I have 6, 8, and 4. So the LCD of 6, 8, and 4 is 24. Okay, so 24 is the LCD of all of them. If you don't know how to find the LCD, please look up. A simple thing to do would be look at all the multiples of 6. 6, 12, 18, 24, 30, and so on. Multiples of 8. 8, 16, 24, 32, and so on. Multiples of 4. 4, 8, 12, 16, 20, 24, 28, and so on. So the first number, which seems to be common for all three, is 24. And that's how you find the LCD. There are other methods, of course, but I'm just showing you one method. Okay, so now that I know what the LCD is, I'm going to multiply each term with that LCD. Okay, so then what happens? The 6 goes into 24 4 times, 8 goes into 24 3 times, 4 goes into this 6 times. Then you distribute. So here is where you have to be careful. You have to distribute the 4 with both the x and the 3. So you have 4x plus 12 equals 9 plus 6x minus 30. So combine the like terms on the right hand side. 9 minus 30 is negative 21. Then bring the 6x to the left and the 12 to the right. And then your answer is this. Okay, you can always check later whether you got it correct or not. It looks correct to me. Doesn't hurt to check. Oh, right. Okay. Okay, so more equations. So let's see how to do this first one. For each equation, write a value that makes the denominator 0. These are the restrictions, and then keeping the restrictions in mind, solve. So you have restrictions in these set of equations and not the previous ones, because here you have a variable in the denominator. So if you look at the first one, it looks like the x value that will make all of these denominators 0 is actually 0. So as long as x is not equal to 0, we are good, because then 2x will not become 0, 3x will not become 0. Okay. Once we have established that, we need to find the LCD. So the LCD of 2, 9, 18, and 3 is actually 18, right? So that means 18x becomes my LCD. Okay, then multiply by that. There are lots of other videos you could check out if you're having any problem with finding the LCD. All right, so once we have that, I'm going to cancel. The x and the x goes away. 2 goes into 18 9 times. 9 goes into 18 2 times, and the x remains, okay? 18 goes into 18 1 time, so the x remains. 3 goes 3 goes into 18 6 times, and the x gets cancelled out. So what am I left with? 9 times 5 is 45, minus 2 times 8 is 16x, equals x minus 6. So I have a linear equation. So I'm going to collect all the x to the left and all the numbers to the right. 45 plus 6 is 51. So I divide, x becomes 51 over 17. So 17 times 3 is 51, right? Yeah. So the answer is 3, and 3 is not a restriction. So this answer should be okay. Okay, now let's take the second one. X minus 2 over 2x plus 1 is x plus 1 over x. Again, x cannot equal 0. And the LCD is just 2x. So I'm going to multiply by 2x. Now I start cancelling. The 2x and the 2x goes away, leaving me with a 1. This x and x goes away, leaving me with a 2. So then I distribute. So I have x minus 2 plus 2x equals 2x plus 2. So I have 3x minus 2 is 2x plus 2, which means x equals 4. And that's my answer, and it does not interfere with 0, so that's my answer. Third one, I have 1 over x minus 1 plus 5 is 11 over x minus 1. Here my restriction is x cannot equal 1, correct? Because if x is 1, 1 minus 1 will become 0. And the LCD is just x minus 1. All right, so now this x minus 1 and x minus 1 goes away. This x minus 1, x minus 1 goes away. And I distribute. I have 1 plus 5x minus 5 is 11. So that means 5x minus 4 is 11. 5x is 15. X is 3. That doesn't interfere with our restriction. So this is our answer. All right, so now we are supposed to add and subtract complex numbers. So let's do the first one here. So you are going to just add and subtract as though you are adding and subtracting polynomials, right? This is like two binomials. So negative 2 plus 4 is positive 2. 6i minus I is 5i, and that's your answer. So in the second one, because it is a subtraction, you have to make sure you distribute the second term first. It makes your life easier. So once you distributed, 3 minus 5 is negative 2. 2i plus 7i is 9i. In the last one, first distribute the negative sign and then combine the like terms. So 8 plus 9 is 17. So this is how we write it in the standard form. Put the real part first and then the imaginary part. Okay. So here you're asked to multiply. So the one thing that you want to remember is I is square root of negative 1. I squared is negative 1. So you have to keep that in mind. So when you distribute it, what happens? This and this will become negative 21i squared plus 15i. What is I squared? I squared is negative 1. So when you do that, your answer becomes 21 plus 15i. So that is the answer to this question. So here you're going to FOIL, okay? So you're going to multiply this with this and then this with this. So negative 5 times 3 is negative 15 minus 5i plus 12i plus 4i squared. Okay, so then you are going to keep it like this for just a minute and you are going to replace the I squared with negative 1. So this becomes like so. Then combine the like terms. Negative 15 minus 4 is negative 19 plus 7i is the answer. So in this problem, you are supposed to first convert square root of negative 16 as square root of 16 times square root of negative 1, and square root of negative 1 is I and square root of 16 is 4, so this becomes 4i. Likewise, square root of negative 81 is square root of 81 times square root of negative 1, so this becomes 9i. Square root of negative 4 becomes 2i, right? So now, knowing this, let's go ahead and attempt the two problems. So this one can be rewritten as 5 times 4i plus 3 times 9i. So which is 20i plus 27i, and that is 47i is your answer. Second one, you have negative 2 plus 2i the whole squared, which is nothing but negative 2 plus 2i times negative 2 plus 2i. FOIL, okay? So this goes into both, this goes into both, okay? Then what happens? Negative 2 times negative 2 is 4 minus 4i minus 4i plus 4i squared. Okay, but what is 4i squared? You know that I squared is negative 1. So 4 times negative 1 is negative 4, right? So that means the positive 4 and the negative 4 get cancelled out. So what are you left with? You're left with negative 8i. Okay, all right. So here we are looking at quadratic equations. Okay, so these are quadratic equations. Let's see how to solve them. So here the method that is asked of you is by factoring. So let's do that. The first one, you have 3x squared plus 12x is 0. Your right hand side is already 0, so you don't have to do anything there, right? Look at the left hand side. Between 3 and 12, 3 is a common factor. Between x squared and x is a common factor. So this is what you have when you factor it. So you have two factors. When you set this factor to 0, x will become 0, because if 3x is 0, divide by 3 on both sides, x is equal to 0, right? The second factor, if you set it equal to 0 and solve, x becomes negative 4. So these are the two solutions to the equation. Okay. Now let's do the next one. So in the next one, I have 2x times x minus 3 is 5x squared minus 7x. I'm going to distribute first on the left side. I have 2x squared minus 6x is 5x squared minus 7x. Then I'm going to get everything to one side. It feels to me that moving this to here and this to here will be easier for me, and that's what I'm going to do. So 5 minus 2 is 3. Negative 7 plus 6 is negative x. So that's what. So you can combine it any way you want, but you're going to see that this is what's going to happen. Then factor the x out. Solve. X is either 0 or 1/3, right? So these are the two solutions. Okay. Third one. 7 minus 7x equals 3x plus 2 times x minus 1. So I am going to distribute and FOIL on the right side. I have 3x squared minus 3x plus 2x minus 2. So combine all the like terms on the right hand side and you have this. Move everything over. So I'm moving the negative 7x to the right. It becomes positive 7x. So 7 minus 1 is 6. I move the 7 to the right. It becomes negative 7. So this is what I have. Okay. So now I can rewrite it like so. It's the same thing, whichever way you write. Okay. Now you see how 3 is a common factor. Just take it out. It makes your life easier. And then if you divide both sides by 3, what happens? Sorry. You divide both sides by 3, you're left with this. Okay? This can be easily factored. X plus 3, x minus 1. Okay? So the two solutions are x equals negative 3 and x equals positive 1 are your two solutions. Because if you set x plus 3 equal to 0 and solve, x will become negative 3. If you set x minus 1 equal to 0 and solve, x will become 1. Okay. Now we are going to solve these by using the square root property. Okay. So let's see the first one. So in the square root property, I like to have a perfect square on the left, okay? So which means I'm going to add 7 to both sides. So I add 7 to both sides, then the right side becomes negative 8. I divide by 2, I get x squared is negative 4. Now can x squared be ever negative? No, because when you square a number, it always becomes positive. And even when you square 0, it's still 0, right? It can never be negative. So there is no solution to this problem. Okay. Second one, x minus 3, the whole squared is 36. I take the square root on both sides. Square root and square cancels each other out on the left, and square root of 36 is plus or minus 6. So I have to set up two equations. X minus 3 can either be positive 6 or negative 6, which means x can be either 9 or negative 3. So there are two solutions, 9 and negative 3 both works. Okay. In the third problem, the first thing I want to do to both sides is divide by 3. So when I divide by 3, I get this. 21 divided by 3 is 7. Then I take square root on both sides. So then I have x plus 4 is plus or minus root 7. So I move the 4 to the other side. My answer is negative 4 plus or minus root 7 is are the two values of x. You can leave it like that. Determine the constant that should be added to the binomial so that it becomes a perfect square trinomial. Then write and factor the trinomial. So in order for me to have something here so that this becomes a perfect square. So to find this something, what do? I take the middle term, that is the b, I divide it by 2, okay, and I square it. So that is 49, right? So what I need to add here is 49. When I do that, what happens? If you factor this, the two factors will be x minus 7 times x minus 7, or in other words, this is a perfect square trinomial, x minus 7 the whole squared. Okay, so we're going to do these two by completing the square. So let's do the first one. X squared plus 4x plus 1 is 0. Okay. Your middle term is 4. Take divided by 2 and square. So 2 squared is 4. Okay. So basically what you want is this. Okay, I'm going to do it this way. I'm going to move the 1 over to the right. So it becomes negative 1. So then I'm going to add to both sides this 4 that we just came up with, this 4. Okay. So we are going to add to both sides this 4. So the left side now becomes a perfect square trinomial and the right side is 3. Then we do what we did in the other problem. We take the square root on both sides. We will have x plus 2 is plus or minus root 3. So the answer is negative 2 plus or minus root 3 is my answer. Okay, so take the middle term, cut it in half, square it. That's what you want to add to both sides. So now let's do the same thing in here, but because this has a odd number, it makes it a little bit more difficult. So here I have x squared minus 5x plus 6 is 0. X squared minus 5x is negative 6. So what should I add? I should add this to both sides, okay? So what is that? Let's see. X squared minus 5x. This is 25 over 4. So I'm adding 25 over 4 to both sides. So my left side is a perfect square of this. So the number that comes here is always this number, okay? And then this one is 1/4 because negative 6 times 4 is negative 24. Negative 24 plus 25 is 1, so 1/4. So when I take square root on both sides, I get plus or minus 1/2 because square root of 4 is 2. So the two equations I set up are this and this. And so add 5 halves to one side, this becomes 3. Add 5 halves to one side, this becomes 2. Okay. All right, now we have to use the quadratic formula. So quadratic formula. For quadratic formula, you want to make sure that you bring everything over to the left first, okay? The right side has to be 0. Then this is A, this is B, this is C. And what is the quadratic formula? X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So my b is negative 2 plus or minus square root of negative 2 squared minus 4 times negative 7 all over 2 times 4. Simplify this. 2 plus or minus square root of 4 plus 16 times 7. So that is 2 plus or minus square root of 116 over 8. That's good enough for me. Okay. We can try to simplify this. So 116 is 4 times 2, 8, 36, 29. So this will be 2 root 29. So I don't see any point. So we can just leave it like that. That's good enough for me. So the next one is x squared minus 6x plus 10 is 0. So your A is 1, B is negative 6, C is 10. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So that is 6 plus or minus square root of 36 plus 40 over 2, which is 6 plus or minus square root of 76 over 2. Okay, that's good enough. All right, so now we are asked to solve it by the method of our choice. Let's see, what am I going to choose? The first one is pretty straightforward, isn't it? Divide by 2 on both sides. Take the square root. Wait, this is not a perfect square. You can just leave it like that. Okay, so that is your answer. So this is like, you don't have to write 5 root 5 and all of that. If you want, you can. So 125 is nothing but 25 times 5, right? And 25, so this is nothing but 20, 25 times this, right? So this is the same as 5 root 5. If you want, you can write it like this, or you can leave it like this. I will accept either one. Okay. The next one lends itself to, let's see, um, quadratic formula, I guess, right? So let me erase it here. I'm going to go here and do the second one. So the second one, I don't want to, so first of all, I want to bring everything to the left like so. I can't factor this, so I'm going to use the quadratic formula. So I have x equals negative b plus or minus square root of b squared minus 4ac all over 2a. 4 times 2 is 8, 9 plus 8 is 17. So this is my answer, and I just leave it like that. Okay, that's good enough. So the next one, of course, I have to FOIL first, right? So you have to start with that first. So I have 2x squared plus 2x minus 5x minus 5 is 2. Combine the like terms. Bring the 2 over and use the quadratic formula. Okay. Nine plus 56, 65. And that's your answer. So here you're asked to solve this radical equation. The first one has only one radical, like so. So for solving a radical equation, we are going to square both sides. So when you square a radical, the square and the radical gets neutralized, and this becomes this. So then I'm going to bring everything over to one side and see what I can do with this. I think I can factor this, right? So this will be x minus 6, x plus 3. So which means x is equal to 6 or negative 3. So here you have to check whether both solutions work for you, okay? So if x is 6, square root of 3 times 6 plus 18 works. It's a positive number, so no worries. If x is negative 3, square root of 3 times negative 3 plus 18 won't work for you because you'll get a negative number. So there is only one solution, which is 6. In the second one, I do the same thing. I'm going to square both sides. The square and the square root cancels each other out, but here I end up with the square of a binomial. So I have to expand it. This becomes x squared minus 6x plus 9. So what I did was x minus 3 times x minus 3 on the right side. Then I move everything here. When x moves here, it becomes a negative. 3 moves here, it becomes a negative. This is what I have. This is factorable. So which means I have two solutions, 6 and 1. And they both work for me, so I'm good. Right? 6 plus 3 is 9. And 6 minus 3 is 3. That's correct. Oh, wait. Only one. This doesn't work for you. Only this works. Because 1 minus 3 is negative 2, right? And square root of 1 plus 4 is positive 2. So there's only one solution. All right. So here I have to So in order to make it 1, what will I do? I have to raise this to the power of its reciprocal, which is 2/3. So that's what I'm doing to both sides. Okay. So these two are going to get cancelled. So I will have only x minus 4 on this side. But this side I have 27 to the power of 2/3. Now what is 27 to the power of 2/3? It is nothing but cube root of 27 squared. Okay, so the 3 in the denominator becomes the index of the radical. So what is 27? 27 is 9 times 3, correct? So this is 9 times 3 times 9 times 3. It's something like that, right? So, which is nothing but 3 times 3 times 3 times 3 times 3 times 3. So these 3 can come out of the radical once. These 3 can come out once. So 3 times 3 is 9. So this is 9. So I'll show you again how I did that. So this can be written as cube root of 27 is 3 times 3 times 3, right? But this is squared, which means you repeat it one more time, like so. And because this is a cube root, 3 of these will come out of the radical one time, 3 of these will come out of the radical one time. So that is 3 times 3 is 9. Now I'm going to do the same thing here. But before I do anything, I'm going to move the 12 to the right side. I'm going to divide both sides by 6. So this is what I have. So then I'm supposed to raise it to the power of the reciprocal, like so. Okay. So that means x is going to be equal to fifth root of 2 squared. And what is 2 squared? 4, right? So this is just fifth root of 4 is the answer. Okay. All right. So here you have to make some substitutions. Okay. All right. So what is the substitution that you will use here? So you see how this is actually quadratic in form, except in the place of x squared, you have x to the fourth power. In the place of x, you have x squared. So I'm going to say, let u be x squared. So this middle term, right? That's what I'm taking. So that means if u is x squared, what is x to the fourth power? X to the 4 is nothing but x squared, the whole squared, isn't it? Which means it is nothing but u squared. So this becomes u squared minus 5u plus 4 is 0. This is factorable. So I have two values for u, like so. But u is not I want, x is what I want. So I substitute back. X squared is 4, x squared is 1. Now how do you solve this equation? Take the square root on both sides. So x is plus or minus 2, x is plus or minus 1. So how many solutions do you have here? X can be positive 2, negative 2, positive 1, negative 1. So you have 4 solutions to this equation. So here the substitution I'm going to make is, I'm going to make u to be square root of x, which means u squared is x. So this becomes u squared minus 13u plus 40, factor u minus, wait, 40, 8 and 5. So 8 and 5. So u is 8, u is 5. But what is u? Square root of x is 8, square root of x is 5. Square both sides, x is 64, x is 25. So these are the two solution here, okay? Because here I'm squaring both sides. Previous one, I square rooted both sides, okay? Here you see that this is in the place of x, this is in the place of x, right? So the substitution I'm making is u is x plus 3. So this becomes u squared plus 7u minus 18 is 0. I factor. I have u is negative 9, u is 2. But what is u? U is x plus 3. So x plus 3 is negative 9, which means x is negative 12. X plus 3 is 2, which means x is negative 1. So these are my solutions. Negative 2 and negative 12 and negative 1. Okay. So here, absolute value of 2x minus 1 is 5, which means that 2x minus 1 can be 5 or 2x minus 1 can be negative 5, right? Because either one, when you take the absolute value, it's going to give you positive 5. You solve this, 2x is 6, x equals 3 is one solution, 2x is negative 4, x equals negative 2 is the other solution. Here, I'm going to divide by 2 on both sides. And then I'm going to do the same thing. I'm going to say 3x minus 2 is 7. 3x minus 2 is negative 7. And solve. 3x is 9. 3x is negative 5. X is 3. X is negative 5/3. Okay. And that's it.